Hey, this is my second video on logarithms. We have a problem here. So for x, if log of 16 to base x plus log of 32 to base x is equals to 18. Okay, so the solution to this one is right here. So we are going to solve this problem. First of all, we recognize that we don't have a particular base that we know, except that here in this question we have just x, and on the right hand side we also recognize that we don't have logarithm. So in order for us to make sure that this problem doesn't become difficult to us, we introduce some way of rewriting this one in a different way that will make sure that on our right hand side we have something that we can solve. So what I mean in that is that 16 can be written as 2 to the power of 4. Then that 2 can be written as 2 to the power of 5, and we will maintain 18 on the right hand side. Then we can introduce this one to the front and this one to the front. There is a law of logarithm that says that. So we have 4 log of 2 to base x plus 5 log of 2 to the base of x equals to 18. Okay, now you can notice that this part here and this part, they are the same. So if you call this one k, so this is like having 4k plus 5k, so you have 9k, right? The same as logarithm of 2 to base x times 9, which is the same as 18, right? So that's a way of, little algebra there, and you simplify to get that. So you can divide by 9 both sides, because this here, they are united by multiplication. So we have log of 2 to base x is equals to 2. Now it simplifies to a very nice logarithmic equation here, and so you can say x to the power of 2 is equals to 2. So you transform this one from logarithmic to indicial format. So this is in index form, and the question is asking us what is that value of x which when you square you get a 2, and the answer is just square root of 2. Okay, so you can leave it in that form, and that will be the answer to that problem, right? So let's solve another one here, and this time round we are going to solve a problem involving making a certain quantity the subject of the formula. And the question reads, make k the subject of the formula in this equation r is equals to square root of k squared plus a squared all over h times g, right? So we want to make k the subject here, and you can see that it is embedded under a root. And so what we can do is to actually square both sides, and we can isolate k among those. So we have to multiply by, we have to get rid of this square root sign, and we can do that by squaring both sides. And so we have r squared is equals to k squared plus a squared all over hg. Okay, so then we multiply both sides by hg. So we have r squared times hg is equals to k squared plus a squared. Still want to find k, so we can take our a squared to the left, and so that will be r squared hg minus a squared. Okay, when you rearrange, that's what you get. And now from here we're almost done. We square root both sides because we need k and not k squared. So we square root both sides, and you're going to have r squared hg minus a squared, right? And you must leave your answer in plus or minus, because the square root of a number can either be positive or negative. So that's the value of k, and this is the solution. This is how you're supposed to leave your solution. It is k is equals to plus or minus square root of r squared times h times g minus a squared. And I want to caution those who are tempted to square rooting separately here and leaving their answer as r hg minus a squared. You can't do that unless you have a way of factoring it out and getting the square root. Thank you.